As the demand for sustainable and energy-efficient buildings grows, the concept of transparent solar windows has emerged as a potential game-changer. These windows, which can generate electricity while maintaining transparency, offer a unique opportunity to transform office buildings from energy consumers into energy producers. However, the question remains, can they meaningfully power office buildings, or are they still in the realm of hype? This episode explores the evidence, limitations, and potential of transparent solar windows in the context of modern office environments. Could transparent solar windows meaningfully power office buildings, and what are the practical and economic implications of such a shift?
75%. That is the certified cut-in energy cost from a new type of glass. Tested and verified in a Shanghai lab in early 2025. Glass that generates its own electricity.
A new type of glass claims to slash energy costs by 75% in office buildings. But is this figure realistic? Research on semi-transparent photovoltaic (BIPV) windows suggests they can reduce cooling loads by up to 16.3% and improve thermal comfort in office buildings. However, no study has yet confirmed a 75% reduction in overall energy costs. Imagine if office buildings could become nearly self-sufficient in energy use with this technology. This could lead to widespread adoption of smart windows and a significant drop in commercial energy bills. However, the high cost of installation and maintenance could limit its appeal for smaller businesses. Simulations show net zero energy ratios of 65.1% for south-facing windows in Changsha, but these results depend on factors like building orientation and climate.
Being a pure energy consumer and starts becoming, in part, its own power source. You heard that right. The windows themselves, generating real, measurable electricity. And that is just the beginning.
What if office windows could power the building they're in? New research suggests it's possible, but with challenges ahead. Recent studies show that transparent solar cells, made with materials like tungsten oxide, can achieve up to 7% power conversion efficiency, while maintaining 46.7% light transmittance. These cells are being developed for use in smart windows, which could allow buildings to generate their own electricity. In the future, office buildings with transparent solar windows might generate enough electricity to power their own lighting and systems. This shift could lead to lower energy bills and a more sustainable urban environment. However, widespread adoption would require advances in energy storage and seamless integration with current building designs. Their performance in low-light conditions and compatibility with existing building infrastructure remain key challenges.
Sink at nearly absolute zero. A simple panel, built from common materials for little more than the cost of a sheet of plywood, can radiate heat directly through a window in the...
Could low-cost radiative cooling panels be a game-changer for office buildings? Radiative cooling technologies channel excess heat into outer space or cooler environments, potentially reducing temperatures in the built environment. Despite progress in research, the transition from laboratory breakthroughs to widespread practical deployment remains challenging. In the future, office buildings may explore the use of low-cost radiative cooling panels as a complementary technology. These panels may be made from materials that are suitable for building integration, though specific details on materials or design compatibility are not provided in the evidence. However, the integration of such technologies would likely require careful engineering and testing to ensure compatibility and effectiveness in real-world conditions. The transition from laboratory breakthroughs to widespread practical deployment remains challenging, particularly in ensuring economic viability, scalability, and performance in various environments.
Construction. By 2030, the Department of Energy expects data centers will eat up 17% of all electricity made in the United States. It's pretty simple. The grid was not built for this.
As data centers consume more energy, could transparent solar windows help power them? By 2030, data centers are expected to consume up to 17% of U.S. electricity according to energy forecasts. Transparent solar windows, or building integrated photovoltaics, BIPV, are being installed in commercial buildings at a cost of $600 to $1,100 per square meter. By 2035, transparent solar windows may be a standard feature in new commercial buildings, contributing significantly to energy needs. However, their capacity to meet the full demand of data centers may still require pairing with other renewable sources like wind or grid storage. This hybrid approach could help balance the energy needs of high-tech infrastructure. In favorable markets, BIPV offers a self-consumed levelized cost of electricity as low as 0.08/kWh, undercutting retail commercial tariffs. While transparent solar windows show promise in reducing energy costs and contributing to a building's power needs, their current limitations in efficiency, cost, and scalability suggest that they are not yet a complete solution for powering office buildings on their own. However, as technology advances and costs decrease, they may become a valuable component of a broader strategy for sustainable building design. The future of transparent solar windows is plausible, but it will require further innovation and real-world testing to fully realize their potential.